comments, for any questions that you have. Webinar. So we'll jump in here. Valve positioners. We're going to start with what they are and what they're used for and how they operate. So the valve positioner is going to be this part of it here, right? Its job in life is to put a valve, a control valve, into a particular position, percent open, to regulate, could be flow, could be pressure, some parameter that you want to control with a control valve. So this is a schematic, just a basic one, kind of showing a control loop for a valve positioner. You know, here we have a flow meter measuring flow in the pipe. So in this case, we are doing a flow control. This happens to be an ultrasonic clamp-on flow meter. That flow information, the flow reading of, say, gallons per minute, is fed to the control system. And the control system is really the brains of what to do, what control to do, right? So that could be a PLC, that could be a DCS, that could be a single loop controller. And that's where an operator will be able to put in a set point of, I want, say, 100 gallons per minute. And the control system will then feed typically a 4 to 20 milliamp signal to the valve positioner. So if it's 100 gallons per minute and it's only flowing 90, it's going to increase that 4 to 20 milliamp signal, telling that positioner to open the valve a little bit more, and the valve will start opening a little more to achieve that 100 gallons per minute. The valve positioner is just reacting to that 4 to 20, and it's just turning that 4 to 20 milliamp signal into a pneumatic pressure signal output that is making the valve open or close. So really, it's a lot of questions we get often about, well, how about an I2P versus a valve positioner? I2P standing for current to pneumatic transducer. So I2Ps are, we'll start with them. Really, I2Ps take that same 4 to 20 milliamp signal and they turn it into a pneumatic signal output for the valve. A typical control valve will have a actuator that is called, say, a 3 to 15 psi actuator, meaning 3 psi could be fully closed and 15 psi could be fully open. You can get them in 6 to 30 psi as well, but 3 to 15 is the most common. So an I2P will take a 4 to 20 milliamp signal and turn that into a 3 to 15 psi signal. So as you can see here, right, we go 4 milliamps will be 0 psi. 12 milliamps, which is 50% of our signal, would be 9 psi, which is 50% of the pressure range, and 20 milliamps being 15 psi. So that does the job. That makes a valve open to about the amount that you want. And really, the main difference, one of the bigger differences, at least, in a valve positioner, which would be one of these guys, is it still takes that 4 to 20 in and sends a pneumatic signal out to the valve to open and close it. But a valve positioner actually monitors the position of the valve itself. In this case, there's a mounting bracket and arm that attach to the stem of this valve so that the positioner can monitor what position the valve is. So really, what that's doing is, if you say send 12 milliamps to that positioner, instead of just sending 9 psi out, it's going to drive the valve to 50% open because it knows where 50% open of that valve is. So whatever pressure it takes, it's going to drive that valve to the percentage open that you're calling for. With the I2P, it's going to send out 9 psi, and that may or may not be 50% open. You wouldn't be able to tell with the I2P because it does not monitor the actual position of the valve itself. So here's a line drawing of that for an I2P. So we have like a DP here doing, say, a flow rate coming down a line. That's going to our controller where we have our set point, like we talked about, of how many, say, gallons per minute we want to flow through this line. That controller sends our 4 to 20 milliamp signal to our I2P, telling the I2P how much pressure to put out. In this case, that is just the I2P current to pneumatic transducer. And that's going to output our pneumatic signal to our control valve. So 12 milliamps being 9 psi, for example. And that's the whole loop, basically, of all of it. And that will open and close the valve and control the flow rate out. But again, as I mentioned, the I2P does not monitor the position of the valve itself. So it doesn't know if the valve is all the way open. So here is kind of a condensed line drawing for the valve positioner. So the main difference here is, we still have a flow meter feed a control system with a set point in it, and that control system would be feeding a control signal to our valve positioner. And our valve positioner is going to output a pneumatic signal to our control valve, telling it to open or close. Main difference here is being our position feedback. So as you can see here, the positioner is monitoring the actual position of the control valve itself so that it can drive that valve to the correct position that's being called for. Another side benefit of that is valve positioners typically have the ability to give back a signal, a reading, whether it be a 4 to 20 or a heart signal. In some fashion, it can give back the valve position as a feedback back to the control system so that the control system can monitor the position of the valve and make any corrections needed if the valve is not in the position that it's being called for. So there are in a valve positioner, there's a couple different internal mechanisms that can be used for making the actual positioner work. One of those is a spool valve. The spool valve is what is also used in an I2P. So a spool valve is this component here, and it's essentially a shuttle that slides up and down in this case based on what this whole part of it is telling it to do. So this would be a force balance system. This is how a traditional positioner functions. You have here, this would be a shaft that is linked to the stem of the valve in a linear valve, which turns a cam, and that cam turns an arm against a spring and balances that against the pressure from an I2P or a pneumatic signal that would be pushing against the spring in this direction. So with this, I've got a little bit of animation that you can see. So this would show when the 4 to 20 milliamp signal starts increasing our input signal. What that does is from the I2P, it pushes on this diaphragm here from the I2P that's inside of this mechanical positioner, which pushes against this spring, moving this arm. And as you can see, that pushed up our spool valve. So it is now pushing some more pressure to our control valve. You can kind of see that our diaphragm has started moving down in the control valve, which starts to stroke our control valve down. So in this case, that would be, air to open function on that. So once that happens, you can see here that the cam has now turned. That would be the reaction of the control valve actually starting to move. So once that cam starts to turn, it moves our arm, which pushes back against our spring here, which is our force balance. And that's going to start pushing back against this arm, which is going to start moving our spool valve shuttle in the opposite direction. Once we start to get to the actual set point that we want with our control valve, which would be here. So now we've reached equilibrium within our control valve. Our valve is in the position being called for, and everything is back to a steady state position where our spool valve is back to its normal state. So these mechanical positioners, which is what I just kind of went through, our animation would be a mechanical positioner. And that's where positioners really first started. They use mechanical cams, and there's pivots and arms and springs, and it's force balance like I was talking about. This is an example of one. This is the 760 from Siemens. And you can see this one has an I2P right here where the 420 milliamp signal would come in, and our pneumatic signal comes out to push against this spring to make everything happen. These ones have the benefit of they can also be a pneumatic positioner. We don't have to have the I2P. We can actually take say a 3 to 15 PSI signal into this positioner, and it can then position a control valve based on that pneumatic signal coming into it. We can do it electronic as well with this I2P 420 coming in. A smart positioner, and this is an example of the PS100 from Siemens. There's a PS2 as well. These ones don't use any mechanical components in it. It's completely electronic at this point. So there's no cams to adjust, there's no springs, there's no mechanical adjustment to zeros and spans. Everything is done electronically. So with these ones, you can do electronic calibrations where it can calibrate itself. There's no cams or linkages or springs. These ones only can take an electronic signal. We cannot take a pneumatic signal to these positioners. They can only take a 420 typically. And they can give a lot more information about what's going on in the valve. You can start to get into a lot of diagnostics and monitoring the health of the valve with these smart positioners. They also, a lot of times, have the ability to have heart communications or a foundation field bus, let's say, or a Profi bus or things of those natures where you can get a lot more information from them. And they can use either spool valves or piezoelectric valves. So what is a piezoelectric valve? Well, spool valve we kind of just went through, right? Shuttle moves air back and forth. One downside of a spool valve is that it always has air moving through it. So if it's moving the valve, it's pushing the air to the actuator of the valve, and that's where the air is being used. If it is not moving the valve is stopped in its position that it should be in, it's not moving anymore, a spool valve bleeds air to atmosphere at that point. It's always moving air through it. So it's always using air no matter what. A piezo valve is a technology that Siemens started using in its positioners. Kind of got it from their medical side of things, where gases are really expensive and they wanted to conserve as much of them as they can. They started using these piezo valves. So it's a piezoelectric crystal, and piezoelectric crystals are pretty common these days. That's how ultrasonic level transducers work, as a piezo crystal. And basically what they are is it's a crystal where when you apply voltage to it, the crystal itself deforms and changes shape. So in this little illustration here, it's kind of showing here my valve would be closed when I have no voltage to the piezoelectric crystal. And as I apply voltage to this piezoelectric crystal, it deforms, opening, allowing my valve to now start passing air through it. So these are used in a couple of the different Siemens positioners and their smart positioners. And one of the big benefits of it is when it is closed, it is a tight shutoff. It's a no bleed shutoff. So when you use these style of valves inside of the positioner, the only time the positioner actually uses any air is when the valve is actually moving. So if the valve is sitting at steady state and not being stroked, there is zero bleed from a positioner that uses these piezoelectric valves. So and Wes is gonna cover that a little bit more in detail a little later on the benefits of saving air with your valve positioner. It also gives some benefits like being able to tell if the valve has do a leak check on it and things of that nature. So at this point, I am going to go ahead and have Wes Blocher. Let me find him here. He's going to take over from here. I'm going to make him the presenter so that he can kind of take over on his part of it. I apologize. I'm trying to just find, here he is. Find him in the list.
I'm here.
All right, Wes. You should have control, be able to share your screen now.
You said that like I know what I'm doing.
Hold
on here. Am I there?
We see your screen. Yeah, you just need to make that your presentation mode.
Yeah, I'm trying to get all this stuff out of here. I got all this.
Just click the little button down. Yeah, go to the left of where you would make it bigger and smaller.
But I've got all the names covering that stuff up on my end.
Just if you
there you go. Let's see if we do this right here. There you go. Get rid of. How come I can't get rid of everybody? All right. Can you see my screen?
We can see it, Wes.
All right. Is it good? Is it clear?
Yes.
All right. Hold on. All right. Well, let me go back to where I am. All right. Let's talk about the PS100. The Siemens PS100 is our newer product. As Matt was saying, it is piezoelectric based. There are no springs, cams, things like that. The problem with the old cam stuff was that most of them came with 3 cams. You had a linear cam, and you had a quick opening cam, and you had equal percentage cam, and that's what you got stuck with. I mean, if it worked, good for you. If it didn't work, well, not good for you. Okay. If it did not work, then it's what it was. And you were kind of had to work around that. The beauty of one of the beauties of digital is when I don't have that constraint, I don't have that, I can tune this positioner to whatever valve I have. It doesn't really matter. Butterfly valves or linear valves or ball valves or whatever, and I can get the best bang you're going to get for your buck. If you're using a valve, and what I see every day, because I'm an old valve guy, okay, is what somebody needed was a really expensive linear valve. What they ended up with, because it was cheaper, was a ball valve or a butterfly valve or something that's probably not the world's best control. Now, can I make all your problems go away? Absolutely not. However, with a digital positioner, I can get you the best bang you're going to get for your buck. Okay, I'm just going to get that. And the heart of this thing, of the PS100 and all digital positioners, is one's that PC board. It's got a chip on there like a computer. So now I've got something watching the process. I've got something not just mechanically moving, but I'm watching the process. And as Matt was saying, in the digital positioner world, the PS100, there's no zero screw, there's no span screw, there's no drift. Okay, what it does is when you calibrate, it draws something called a valve signature. All valves are a little bit different, and I don't care how linear somebody says their stuff is, it's not perfect, but that's okay. And it looks at that and it says, okay, this is what we want from now on. Okay, this is what we want. So as things change in your valve, maybe somebody tightens the packing gets a little looser, the springs get a little, they get some wear on them, the air pressure varies a little bit. The positioner sees that and does what it can do to keep you on the original calibration curve. That's the beauty of this. In my day, when I started this, messing re-zero and re-spanning things, that was just part of life. That was work. That's what you did. You don't have to do that with a digital positioner. The PS100, same as our PS2 flagship positioner, just goes. It keeps on there. Now, the question comes, what if it can't? Something gets in the valve and it can't shut the valve. It can't open the valve. An air line blows off. Somebody turns the air off. It will let you know there's an error. It will tell you, I can't do this anymore. Okay, which is a good thing. Now, before we mess up a bunch of product or something, we know about this. The other part of that is that black block on the right over here. If you can see my arrow, that's the piezo block. The magic piezo crystals are inside this block. All the air that this valve gets comes in and out of the piezo block. It goes in the piezo block, goes the actuator, does whatever, and then vents back through the piezo block. So I'm controlling air in and I'm controlling air out. Okay, that gives me good tight control. That makes things a whole lot better than they were in the analog days. All right. Well, this is the picture of our product. This is what this is this is a lightened up version, more or less, of our PS2 flagship product. It looks a little different. Now, right now, this positioner has no approvals. It doesn't have heart. That's in the works. It's coming. And it doesn't have all the acres of diagnostics that our flagship PS2 has. A lot of people don't need that stuff. But what it does have, it comes with, in every one of them, a digital out, okay, analog out. It comes with analog input and digital input. Okay, so what? Who uses that? Well, a lot of people use those things for making it goes to an interposing relay or something like that, to have something else happen into a fail-safe, do a fail-safe thing. If you look at this, there's not a whole lot to this positioner. That way for a reason. You get aluminum or you get the clear plastic. And it's got the four, but they all look the same, 4-button system. And all you need to tell us is what valve this thing's going to, so we got the right mounting kit, and whether it's double acting or single acting. Makes it pretty easy to order, easy to operate. Now, the other thing is when you look at these things, you say, well, you know, what do I get? This is it. What you're seeing is it. As I was saying before, the air, number 4 here, air comes in. This is a double acting. How do I know that? Got 2 outputs. Okay, I've got 3 and I've got 5. So I'm going to one side or the other of the actuator. All right. I've got the 4 buttons. One thing about all of our digital positioners, our flagship product and the PS100 is we always have the buttons. Okay. That means you don't get a blind one. You don't get one where you have to go find a handheld or a computer or something. Our flagship product, you can use that, and pretty soon when we get hard, you'll be able to use it with this. But you can always go those buttons and calibrate it. You can put it in manual and stroke it, do what you want to do without having to have any other device if you don't want to use it. All right. If you look at this cutaway, what you see here is this is the magic piezo block. Okay. One thing this positioner has, which I really, really like, is this. That's the shaft that would go to the mounting lever or whatever. This is your feedback. This is what tells the positioner exactly where the valve really, really is. Like Matt was saying, if you didn't have that, you could have an output, but you really would never know if the valve was where it was supposed to be because there's no feedback. All right. The heart of this is this part right here. This is a non-contact sensor. Okay. In our flagship product, it started life being a potentiometer. And we also offer this as an option in that product. All of these are magnetic non-contact. Now, so what? You know, people say, well, is that good or bad? What do I get with that? What you get with that is a potentiometer, you know, God bless potentiometers, but where you have a problem is it's a mechanical wiper device, right? So if you're in a very high vibration, I'm not talking about kind of shaking. I mean something like a high pressure drop letdown when you've got high frequency tuning fork vibration, and that valve's not moving very much. It's sitting in the same place. It's steady state. Eventually, that vibration will cause the wiper to kill a spot in the pot. Excuse me. If it kills the spot, now that positioner really doesn't know where to go. Okay, it starts to freak out. Well, that's why this was invented. There's no mechanical connection. It's all magnetic. Also, this is not the Hall effect. This is GMR. Okay, most of the magnetic stuff out there, the non-contact, is a stack of magnets. It's the magnet array, and as they're measuring magnetic strength. So as that degrades, you have to replace those magnets. There's no magnet. We're not measuring magnetic strength here. It's more of a phase shift. So what does that say? I don't ever have to replace the magnets. I don't have to go back and say, well, you know, how often do I replace the magnets? Where do I stock the magnets? There's no magnet to replace. That magnet will be just fine long after that positioner's gone. So that's not going to be an issue of maintenance or keeping up with it, because people ask me all the time that have used the magnet array type systems, what does the positioner do when the magnet dies or the magnet doesn't die? Okay, so that's not a problem. All right. If you will look at one of the, yep.
There is a question.
Okay.
So, and the question is, do you have the mounting brackets for different manufacturers' valves?
Yes, I do. We've got a little over 400 mounting kits. Okay. And if you come up with one that I don't have, we'll make it for you. That way we can add it to our library, give it a part number. But that doesn't happen much because we have, like I said, over 400. And the beauty of our kits is we give you everything. The levers, the nuts, the bolts, the washers, and there's instructions in every one of them. So when you get that kit, whether it's for a Fisher 657, a Mason Neal and Cam Flex, a Bray, or a whatever, it's ready to go. It can be put on there, okay? And that's not a problem. We sell kits every day. You kind of have to. Also, if you use, whether you use our flagship product, whether you use the analog 760 or whether you use the new PS100, the drillings, everything's the same. So the same kit goes to all of them. It's not like, oh God, I got to figure out which positioner and which kit goes with that positioner. You don't have to do that. It's real simple. All our kits are very high quality. You know, most of them are stainless. So it's not that's not going to be an issue for you. All we need to know is you tell us, like if it's a linear valve, let's just give Fisher, they'll throw this one at Fisher. I've got a 657 size 40 with an inch stroke. That's all I need to know. And we'll get you the right kit.
Thanks, Wes. That's it for questions for now.
All right. If you look at the PS100, it's got a 4-button system. And people say, okay, now what do I have to do to calibrate this thing? It's real easy. Push the button. That's it. It's truly a 1-button calibration. It calibrates. It tells you it's complete. There's no mechanical adjustment to do. There's no, well, where do I start? No, it go out. It'll figure that out. And it truly works. And when we first designed this, and I got one of the first ones, I was like, yeah, okay, we'll see. It's amazing. It is a true 1-button calibration. It tells you it's complete, and then you run. You're done with that. That's especially nice if people have to do this at 2 o'clock in the morning in freezing cold weather, and maybe the guy's hasn't done one of these in a while or ever. It's not hard to. It's not much figuring. There's not a whole lot you can do. It is truly a 1-button calibration. That's not anything special. Every one of them comes just like that. So if you set up one, they're all the same. There's no different models. Well, this one has this. No, they all set up the same. What those other buttons do is I can go from manual or automatic like this picture shows. I'm looking at the automatic. Now, this is what it would look like if it's running. I'm in auto. I'm getting 75%, and I'm at 75%. Life's good. Well, if I go to manual, then I can use these buttons here, and I can stroke the valve. If I want to take it out of service, I can say, okay, hang on. Something's not right. I'm going to take it out of service, and I'm going to stroke it to 50% or wherever I want it to be. That's what it'll do. The beauty of the manual thing also is it will not time out of that for safety reasons. Like if I put it in manual walk off, it'll be in manual. If I don't come back till tomorrow, it'll be in manual. It'll stay there until I put it back into automatic. That way nobody gets hurt. You know, it doesn't just pop out of manual. And the beauty of it is that also, if I go from manual back to automatic, it picks up. It just goes. I don't have to reset anything. I don't have to tell it, I don't care. The signal can be changing. It'll jump right on that signal and start following. There's not any adjustment here. That's what I like. I mean, I calibrate it, I put it in service, and I don't have to go back unless I just want to. All right. And here it is. Yep.
Couple questions for you.
Sure.
One question is the PS100 RF noise resistant?
Yes, that's that's right now. We're slated by April to have the FMCSA ATEX approval. That is wrapped up in that. Yes, it will be. Part of the enclosure and the reason those enclosures designed the way they are is to meet the CE requirements for a noise RFI EMI immunity. So they are immune to a point. No, they are immune now, but I don't have the certificate. I won't have that till April. But yes.
One other question. Is there a recommendation for what level of plant air filtration? What level of plant air filtration is recommended for either the PS2 or the PS1?
Everybody in the positioner business goes by, I can get you the little paper, the little certificate. But what the PS100 and our flagship PS2 has is where the air goes in, there's little screens in there that are about 5 micron. And I will be 100% honest right now with you. If the digital positioner, anybody's, not just mine, has a weakness, it's air. I like clean air. Everybody in the digital world likes clean air. Now, if you go back that analog 760, and, you know, I live in Georgia, and there's a rumor that it's humid here in the summer. And, you know, people say, look, there's air in our instrument water. Water's one thing nobody likes. I like to knock that out. Now, if you fill an old 760 or an analog positioner and you crud it up so bad it stops, well, you can take it apart, dump it out on the table, clean it up, and put it back in service. You're not going to do that with a digital positioner. You fill it, really mess it up, really swamp it, it's done. Now, the piezo block is 2 screws. It can be replaced. If you fill a PS100 or our PS2 with clean, you know, relatively clean water, which I'm not sure I've ever seen that too much, but if you fill it full of water, most of the time it will dry out and it'll go back, it'll work. Now, if you fill it full of compressor goo, oils and all the stuff, it's done. Okay. Clean air I like. I don't, like I said, I'm an old valve guy, and I never ever sold or dealt with a valve that didn't have an air filter regulator on it. Okay. A couple reasons. One, I like clean air. And you really need to put a regulator on there, because if, like Matt said before, all positioners from the very first one to the slickest digital stuff do one thing really well, and that's to correct the error between valve set point and valve position. Well, it's going to keep loading air until it corrects that error. What if it can't correct the error? Something's in the valve, something's, you know, whatever, blocking it. Well, if I've got an actuator that can only take 40 pounds and I don't have a regulator, and I've got 100 pounds or 80 pounds of instrument air pressure, it's going to keep loading. Well, the best thing that can happen is I blow the diaphragm out of it. The worst thing that happen, I turn it to shrapnel. So you need to look at the actuator. There'll be a tag on there of its maximum allowable working pressure, and you need to put your air filter regulator. You're filtering that air. The other thing is you're making sure that no matter what happens, I don't exceed that. I generally back it down about 5 pounds below that, and then I feel pretty good about that. But yes, if you need it, I can get you the official, everybody in the industry uses air quality. Okay. I don't really remember what that is, but I like less than 5 microns. And so does everybody else. And I like clean, dry air. Okay.
Thanks, Wes. One more question here popped up,
Sure.
and that is, can natural gas be used for the supply pressure?
Okay. And this positioner right now, PS100, no. Because now in PS2, our flagship product, we use it on gas pipelines every day. Because it's a no bleed positioner, the EPA likes it. The gas people like it because it doesn't, you know, I don't blow their product in the air. And the other thing is, a lot of those stations, the compressor stations, are unmanned, and you don't put the nasty smelling mercaptan in the air, which causes alarms. Okay. Yes, you can. You can. Now, there are rules with that. It has to be intrinsically safe. And we do, you know, we want clean, dry, sweet gas. We don't want some wet, nasty stuff, because you're just going to mess things up. But yes, we use them on all the gas pipelines across the nation every day, because they don't have air. They just have compressed natural gas. And if you know, like I said, everything goes in the piezo and out the piezo, out of vent. That's threaded in there. You can put a piece of tubing on there, and you can catch virtually all the gas. So you're not, you know, you're saving your product.
Thank you, Wes.
Sure. All right. Here's the thing. It says best in class commissioning. Everything and every product ever made is claimed to be best in class. Well, this kind of really is, which I'll be honest with you, I was a little skeptical. If I have a positioner, and I only make positioners, right? Siemens doesn't make valves. when we manufacture positioners and they go out in the field, we have no clue where that's going. It could go on some giant Scotch yoke actuator, or it could go on some tiny little additive valve, you know, that's a quarter of an inch or something. We don't know. Well, one thing that PS100 does give you, it gives you these things here. Okay, this gives you some options. It kind of helps you out a little bit. Okay, like a small valve. If I pick that, what that's telling it is it's telling the processor to expect a very small stroke and expect a very fast reaction time. So it knows kind of where to look to begin with. Like the booster, okay? That one says boost right here. That's for a booster application. Well, if I've got something gigantic and I have to have the speed, I've got to put boosters. Okay, if I tell the positioner now, it knows to look for that lag because it takes a little extra time, you know, and the field's not exactly the same. It's looking at the valve, but that air is going through the booster system. So it lets it know that there's something between it and the actuator. So it can tune for that. That way I don't get the overshoot. All this stuff is for overshoot. And what I'm trying to do, what everybody's trying to do, is get to set point as fast as I can get there under control. I don't want to overshoot. On the right here, okay, you look there, it says leak test. Okay, well, what's that? Well, here's what the leak test is. Because I'm a no bleed positioner, PS100 and our flagship PS2, same technology, I can look for a leak. Well, if I've got a spring return valve and I calibrate and everything's fine and it leaks, I'm talking about the tubing leaks or something like that, the diaphragm or something. If it leaks, it's going to hunt. This is going to sit there and go to set point, bleed off, go to set point, bleed off, and nobody wants that. Well, because I'm a no bleed positioner, it'll hold the air in the actuator and look at how much movement it gets because of an air leak. And it'll tell you how much that is. So I can know when I put this in service that my pneumatic side's good, especially on a retrofit. I take an old positioner off, I put the PS100 on there or PS2, and I do all that good stuff. It's got some age, so I really don't know, you know, if it leaks. Well, I can test it. Now I can know when I put it in service that it's good. Okay, that's one of the best things going out there. I can know going out, know going in that my pneumatic side's good. Also, what helps with that is, let's say I've got a valve and it's been in service for a good while and everybody's happy, and now it's not controlling very well. Before I go tearing into a valve, I can make sure that it may just be a diaphragm. It may be something very simple. I can go there and do the leak test and say, oh, wow, it's leaking like a sieve. Well, that makes it a pretty simple fix. I know it's in the pneumatic side and I'm not tearing valves down for no reason. All right. One thing that both our PS2 flagship and the PS100 do is they are no bleed. And I've had many people tell me, well, who cares? It's just air. I mean, it won't hurt anything. Yeah, well, it is just air. But when you pay to compress that air, now you've got an expense here. Well, the whole piezoelectric thing, as Matt was talking about, came from our medical division. Very high dollar specialty gases. They didn't want them to bleed everywhere. Utilities in Europe, especially Germany, have been expensive, very expensive compared to our utilities here. So somebody figured out, hey, you know, I'm walking past these analog positioners and I can hear them just hiss air. Well, how much is that costing? Oh, well, can we do something about that? And some people came to Siemens years ago, and we could do something about that. If you look at this and you say, okay, if I'm not bleeding, we went through this and we said, okay, what's bleeding? How much? Well, we looked across the industry and we kind of picked the middle of the road positioner, not the worst, not the best, just bleeding. Okay. And this thing's on service for 24 hours, just sitting there bleeding. How much does it save? Well, if you do the math here, all this calculation is how much electricity at 7 cents a kilowatt hour it took. Now, we got with Ingersoll Rand, because we're an OEM for them, and we tried to sit down with the compressor gurus and say, well, okay, what about wear and tear on compressors and maintenance and this and that and the other? We never could come up with a number. Neither could they. Well, is it a screw compressor? Is it a reciprocating? How old is it? How big is it? We never could come up with an extra number. So if you look at that number at the bottom, the $584.92, that's what it costs you not to have a PS100 or a PS2 in just air savings. Okay, electricity. Now, there's another savings. I have no idea what it would be, compressor maintenance and things like that. One thing that I have seen is that, and it happens, I guess, more than I thought it did in the beginning. You've got a compressor, an air system, and it was put in a plant, installed in a plant, and it was supposed to cycle on and off. Well, now you've got leaks and things have been added. It just runs. And a lot of people just want anything they can get to get some capacity off that system, so it just run all the time, because new compressors are kind of expensive. Well, that's what you can expect at 7 cents a kilowatt hour minimum. Okay. Again, that's going to vary from plant to plant, facility to facility, but you're going to save a lot of money one way or the other. Now, Matt brought up natural gas. Well, in the natural gas world, even at the lower prices that gas is on the pipeline level, you're talking $2,500 to $3,000 per positioner. And again, that's just gas, not the energy to compress it or anything. That's just gas. So yes, that's a big deal. Again, most people don't think about it being that much money. It's that much money. And again, the PS2, our flagship product, and PS100 are the same technology. They're piezoelectric, they're digital. PS100 doesn't have all the lights, bells, and whistles that our flagship product has, but it does have the same technology, and you will realize the same air savings from that. And if there's any questions, I'll be glad to answer them. Thanks very much.
Yeah, we have a couple more here, Wes. It looks like for air quality, it looks like there is an ANSI.
Yes, there is.
Spec on that, which is 7.0.01.
Yep.
Is that, I guess, do you have any comments on that spec?
That spec is, like I said, it's an industry standard. Everybody in the industry that kind of years ago kind of fell to that. And everybody says, okay, this is what the minimum we're trying to tell every customer, this is the minimum air quality we have to meet. That's best. Everybody's positions were designed to operate there. Everybody's. So, good or bad, that's it. I've never had any trouble with any positioner operating at that level. Okay. And yes, we do other things, nitrogen, and that doesn't matter. So yeah. And you'll find that from anybody who makes positioners.
Very good. Well, that's if anybody else has any other questions, go ahead and you can put them in the chat box. If you have any that you think of later, there's my contact information showing there. We'll give it a few more minutes here, a few more seconds. If anybody wants to ask any more questions, feel free. We'll wait for just a little bit here. Oh, here's one. A couple more coming. So One, Wes, is what happens when the positioner is in manual mode and you lose the loop power?
It'll go to sleep. No matter what happens, see, what's going to happen is when you lose power on either positioner, now like I said, the flagship product, you can get an option there where it'll fail freeze. What'll happen is in PS100, it'll go to sleep. It'll vent, and the valve will fail to wherever the spring fails it to, fail open or fail close. If it's a double acting, depending on how you put the tubing, which side you put the tubing to, the valve will either fail open or fail close. Now, when the power comes back on, there's nothing to reset or anything. It just wakes back up and goes right back to working. Okay. Now, right now, PS100 doesn't have all the high-level diagnostics. PS2 will log that event in the diagnostics. So I can go in there and say, what happened last night? Well, it'll tell me what happened and when it happened. Okay, if I want that. Again, PS100 is the same technology, just doesn't have all those lights, bells, and whistles. But it'll just wake up and run. You don't have to reset or anything.
All right, and I guess a question that just popped up in response to what you were just saying is, at what milliamp value does the positioner go to sleep?
Okay, when it goes below threshold voltage is probably 6 volts or something, depending. I run my demos on a 9-volt battery. Also, the way the microprocessor handles that, it doesn't get stupid. There's, especially older devices, sometimes if you were kind of toggled around threshold voltage, the device would act funny. That doesn't happen. It's either off or on. It won't sit there and get stupid. But threshold voltage is very, 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 very low. Okay. Again, I'm not doing a lot of mechanical things. So threshold voltage is at 4 milliamps. I mean, as you start to drop below 4, 3.8, 3.6, as long as the voltage is there, it'll run. And we run, against my better judgment, people will split range positioners, and they'll run 1 4 to 20 out there. 20 volt. Oh, I can run 2 positioners like that. It's not a problem. Obviously, if you're running the wires a long distance, you're going to lose a little of that. But the voltage, the PS2 and PS100 are probably 2 of the lowest power consuming positioners out there.
Thank you, Wes. Another question here is, can the PS100 be used outside, I think outdoors, or in a Class 1 Div 2 area?
PS100, yes, can be used outdoors. Right now, like I said, there are no area classifications at all until April. Right now, we're in the middle of all the FM, CSA, ATEX, CE, UL, whatever stuff, which is expensive and not fast. But yes, soon it will have that. Now, our flagship PS2 has all that stuff. So yes, you can use it outside. We're assuming 9 times out of 10 that the valves are outside. It'll be NEMA 4X is a minimum, and it'll be fine.
Okay. And then question about when the positioners are in manual mode, and if SCADA can interact with them while they are in manual mode.
What? I don't understand now. What?
So if the positioner's in manual mode,
right,
be operated by SCADA when it's in manual?
No, not at this point. No, not PS100. Well, see, that's one reason that even our flagship product, all that can be done remotely after it's calibrated the first time. Okay, the very first time, soon PS100 will be that way. But for safety reason, before you mangle up any linkage or mess up something or kill somebody, you have to be right at the positioner and calibrate it. Okay. Once it's calibrated that first time, then I can sit in the control room with the software or whatever, some sort of heart communication, and I can look at it and say, well, go to manual, recalibrate, do this, do that. But the first time, no, it's got to be done there. And like I said, it will not default on its own away from that.
And there is a question here about what is the impedance of the input?
The impedance of the input? Oh,
yes.
It's very small. No, you don't need resistors or something like that. It has that. I'd have to look that up, but it's not much. I mean, you don't have to, like I said, it's not like some things you have to have a resistor, like a 250 ohm resistor no, you don't have to have that. The impedance is very low. I'll have to look that up.
Thank you. And is there a battery backup option?
No. Well, let's take that back. There is no batteries in either of our products. There is no battery backup. However, like in the PS2, it'll hold about 2.5 years worth of data inside. It's in non-volatile memory. Anything like the PS100, if I calibrate it and I put it on the shelf or the power goes out or I just turn it off for months, years, whatever, that's not going anywhere. It's just burned in there. There's no, you're not losing anything, but there's no battery.
Thanks, Wes. And one more question here that I see is if you could comment kind of on pricing levels of our positioners.
Pricing levels? Okay. Well, truth in advertising here. For a digital positioner, our flagship product is probably the least expensive on the market. It's also the largest seller in the world, our PS2. PS100 was specifically designed to have the saving features, the air savings, the ease of calibration, all that stuff, but it's a little smaller, well, a little different. It's a completely different package, but it's made for people who want a little better deal. And we're talking about, not having, everybody doesn't need all the full diagnostic stuff. Okay. Because our flagship product, even at that price, there is no smart, kind of smart, super smart. You don't have to order that. They all come with full diagnostics every time. It doesn't cost, it doesn't cost us any more to put it in there. It's there. Okay. PS100 doesn't have that. It's as bare bones of a digital positioner as you're going to find, and priced that way. Okay. So if you want the digital control and you want the air savings and things, and you really, hey, it's a butterfly valve control and some water that nobody really cares about. It's not going to hurt anything. I don't really need the diagnostics to troubleshoot this valve. It's for you. Okay. If you need the other stuff, that's what our flagship product's for. To be honest, if you look at digital positioners, when they first came out way back, there was this huge price difference between a digital positioner and the analog stuff, like our 760. That price difference is gone. Digital positioner still can be very expensive. Some people's, ours is not. And the PS100 is for those people who, analog's good, but they'd like to have the extra stuff, the digital stuff, the better control. That's what PS100 was designed for. So yes, it's more than price competitive with anything in a business.
All right, Wes. That is all I see, and thank you for doing this with us, everybody on here. Thank you for attending, and we will out here for a couple more seconds here and see if anything else pops up. Other than that, that's the presentation for the day.